So let's cover optimization. Optimization problems involve modeling a mathematical function from a word problem. And then you have to find, obviously, the absolute minimum or maximum value. That depends on what the question asks for. So you're essentially going to be given a word problem. You have to use all the information from the word problem to create a function. And you're going to find the absolute minimum or maximum value of that function. Now, you will use the closed interval method to find the extreme values. The extreme values are absolute min and max. Make sure that you identify the values of the function at the endpoints, okay, if they exist, as these values could be extreme values. Essentially, what that statement is, determine the domain of your function. So x is an element of whatever the case may be. Sometimes you may have x is an element of real numbers. Sometimes you have a minimum x value that you can insert into your function, and you will also have a maximum x value that you can insert into your function. So let's just say 3 and 6. So it can take on values from 3 to 6, inclusive of 3 and 6. What I'm saying in the statement here is that you're going to determine the lowest x value that your function can take and the highest x value that your function can take. And then you're going to determine the y value when x is equal to 3 and determine the y value when x is equal to 6, because those could be extreme values. Okay, so here are the guidelines to solving optimization problems. Okay, I always recommend creating a sketch of the problem if possible. For example, create a sketch when a triangle is involved in the question, because normally when triangles are involved, you're going to be using trigonometric functions, so a sketch is always helpful. Then identify the endpoints of the function if they exist. So these would be your endpoints here. Okay, so the minimum x value and the maximum x value that you can insert into your function, basically get the domain. Then you're going to apply the closed interval method. So you're going to locate the critical numbers in the interval, this interval here, the domain, and calculate the y values. Okay, then you're going to calculate the y values of the endpoints of the interval. That's what I was talking about. Determine the y value at x is equal to 3 and the y value when x is equal to 6, because those could be possible absolute max and absolute minimum points. Then once you get A and B, so what I mean by A and B, this step and this step, the smallest y value obviously is the absolute minimum, and the largest y value is the absolute maximum. So that's how you handle optimization. Basically, what you're doing is getting a function from some information that you're given in the question, and then you're going to find the absolute max and absolute minimum. And what I highly recommend in this section is it's useful to be able to know how to plot or just have a rough idea of how the function that you obtain from the question that you are going to create from the question looks, okay? How it roughly looks on a Cartesian plane. What I mean by that, whether it's an increasing function, a decreasing function, whether it has a local minimum or a local maximum. It's just useful, not being able to plot it, but just to have a rough idea of how it looks. So let's go for an example. All right, here's example 1. You need to find two numbers that have a difference of 100 and their product is a minimum. So take a minute, try this question, and then I'll go through the solution. All right, so let's handle this. So we need to find two numbers that have a difference of 100. Okay, let's make the first number that I'm going to choose x. So I'm going to pick a number. X could be 5, or it could be 200, or it could be 300, or it could be a negative number. It could be minus 60, minus 37. So let's pick my first number, and that number is going to be x. And my second number, okay, let's call that one y. Okay, and I'll explain how we get y now. So my first number is x, my second number is y. So x could be 10, y could be maybe 20, x could be minus 37, y could be 5, whatever the case is. Okay, so I found two numbers, and they have a difference of 100. Okay, so that's important information that we need to include. So it means if I take y and I subtract x, so y minus x, that is going to be equal to 100. Okay, so if I pick y to be 150, then x has to be 50 because 150 minus 50 is equal to 100. Now, usually what we do when we're solving these optimization problems is we want everything, our function, to be in terms of a single variable. We don't want x, y, and z, and a, and b. We just want a single variable, and that's usually x. So what I'm going to do is I'm going to write out this y in terms of x. So y is equal to take the x over onto the other side, x plus 100. So this is what I can do. I'm going to pick a number x, and then once I pick that x, I'll already have the y, and that's going to be x plus 100, my second number. So my second number that I choose is going to be x plus 100. So if x is, let's check if this works and makes sense. Let's say x is 20. That means my second number that I pick has to be 120. 120 minus 20 equals to 100. So that's an important condition that I need to satisfy. Okay, so I've satisfied that condition. Let's get this all out of the way. And then we need to find those two numbers such that their product is a minimum. Now we're going to get our function. So if I'm picking x and x plus 100, what's the product of those two? So it's x into x plus 100. There we go. Now I want you to look at this product here. This is actually a function. Why? When I pick different values of x, I'm going to get different output values. For example, if I pick x is equal to 1, it'll be 1 multiplied by 101. That's going to be 101. That's the product. If I picked x is equal to 2, it'll be 2 times 102. That's going to be 204. There's my y values. So this right here, the product, is the function that we want. So this is how we're going to label it. This product here, I'm going to call it P for product of X. Okay, because the product, what this basically means, the product, okay, you're getting it because X is an input variable into this product function. So this is my product function, X into X plus 100. Now we need to look at what's the minimum and maximum values that X can take. So if you look at the question, there was really no minimum and maximum value that X, the X variable, could take. It didn't say the number has to be, the first number has to be 2 or greater, and the second number has to be less than 1,000. There was nothing. So X is an element of real numbers. Okay, that's what we have. So X is an element of real numbers. We don't really have a closed domain for this question. So let's take a look at this function in a bit more detail. This is equal to x squared plus 100x. And if I had to sketch this out, so this is why I say it's so useful knowing how this function will roughly look. So if I had to sketch this out, it would look something like this. Okay, it would look something like that. Okay, that's how this product function is. You can see it's a quadratic function. So can you see that when I differentiate this function, e prime x, let's differentiate it to x plus 100, okay, because we need to differentiate it to get the critical numbers. We're going to set the derivative to be 0, and that's going to identify our critical numbers. What I'm trying to point out from this diagram is when you set the derivative to 0, can you see that you are going to find that point there? And that point there is already the absolute minimum of this function. So we just need to find this x value here, and our question will be sorted out. Okay, so we've differentiated this function, and we've got 2x plus 100. We're going to set this equal to 0. So this is now going to be equal to 0, and we'll solve for x. So 2x is equal to minus 100. Why am I doing this? Because I'm using the closed interval method, basically. But although this isn't exactly a closed interval, we're still finding the absolute minimum of this function. We know what it looks like. I just set the derivative equal to 0. I'm finding this x value here, okay, because that's the turning point. So 2x is equal to 100. X is equal to 100 minus, 100 divided by 2, and that's equal to minus 50. And there's your answer. X, your first number, is minus 50, and therefore 100 plus x is equal to positive 50. So the two numbers that you need to choose are minus 50 being your first number, and 50 is your second number. So these two numbers have a difference of 100. Okay, take 50 minus 50, you'll get a difference of 100. And when you multiply them by each other, they will have the minimum product. Okay, so their product will be a minimum. So that's how you handle this example. That's how easy it is.